Hi there, welcome to Z Online School. In this video, we'll be beginning a series for exam revision about matrices. This is the first part of the matrices series, which will have a second part. In this first part, we're going to be looking at the simple things like finding the transpose and multiplication of matrices. Of course, we'll find some questions here that will be even a bit more tricky than that, but the underlying principle will be just either multiplication or finding the transpose of a particular matrix. The sources of the various questions that are used in this video are from past papers. If you want to know which past paper exactly, you can just look at the top part of the screen. It will always have the question. Let's begin with this question where we're asked to find m with some power t. What that t means is we are finding the transpose. What is a transpose? A transpose matrix is something you do to a matrix. A matrix has got rows. If I have the numbers 1, 2, 3, 4, this is very important to know because I'll be talking about rows and columns. If we go in this direction, this is our first column, column 1. This here is column 2. Then in this direction we've got row 1 and we've got row 2. This you should always know. Matrices can have letters or numbers, so it doesn't matter what our elements are for now. So when I talk about columns, I'm talking about these vertical parts of the matrix. You can even have a matrix like this. So in this matrix, this is our first column, this is our second column, this is our third column. This is our first row, our second row, our third row. It's important to know what are the columns and what are the rows because there's something we call an order of a matrix. The order of a matrix is the rows times the columns. So matrix M here is a 2 by 2 matrix, which means it's got 2 rows and 2 columns. So when we are saying the transpose, we mean we're going to swap the rows and the columns. The first column is going to be the first row. The second column is going to be the second row. So in this case, column 1, I'll try to explain everything. Column 1 is this one here. It's 1, 2. This is column 1. So we're going to make column 1 row 1. For it to become a row, it needs to be in this direction. We need to write the elements of that column in this direction. And then we'll do the same for column 2. Column 2 of M is 5, 7. So this is going to be written in this direction. And then we'll have 5, 7. It looks like 57, 5 and 7. So you can think of the columns becoming rows or vice versa. You can say the rows are becoming columns. You could also say row 1. Row 1 is 1, 5. It becomes 1, 5 like this. You can see from this goes in this direction, we're going to end up with the same thing. So our matrix, let me just get rid of this row information that I've put here. This here will be our matrix. You can see the difference between this matrix that we have and the earlier one that we started with. Immediately we do that, we have transposed matrix M. So this here in blue is just to kind of give us an idea of what was happening. The main thing we're supposed to know is that I've shown you how you can think of it. You can get the first column, make it a row. The second column, make it a row. Just like that. And you always get this question correct. The next is us finding NM. By them telling us NM, what they mean is multiply matrix N by M. Now, When we're multiplying matrices, always remember that the order in which we multiply them, or the order in which the letters are arranged, is very important. So we'll get matrix N and then multiply it by M. Earlier in algebra, we know of commutativity. If we say x times x or x times y, it's the same as y times x. However, for matrices, that's not the case. If you find M multiplied by N, it won't be the same as the answer we're going to find here. So when you're answering such a question, the first thing you should do is copy the right matrix. Don't take matrix that we have transposed in A. That will be a big mistake. So now, using these two matrices, N and M, we're going to perform matrix multiplication. How do we do matrix multiplication? First of all, it's best that you write the matrices kind of multiplied by each other, like this. This shows that you are multiplying them. Notice the brackets that we're using here, they should never be straight. If you want to write them with straight lines, you better close them like that and make them square brackets. Sometimes people prefer these types of brackets, but the parentheses or the brackets that you use for a matrix should never be straight. That means something else. So to perform matrix multiplication, we multiply the row of the first matrix by the column of the second matrix. Get this part here, which is the row of the first matrix, and multiply it by the column of the second matrix. Remember, for matrices, it's always row by column. This is a very important statement you should remember. The order is row by column, multiplication is row by column. It's always RC, R by C. Now, when multiplying here, we'll get the first number in the row and the first number in the column and multiply them just like that. NM is going to be 0 multiplied by 1. This one here, don't mistake it for this one here. So 0 multiplied by 1, and then we're going to add it to 1 multiplied by 2. So first row, first column, just like that. This one by that one, this one by that one. Don't forget that order. After we're done with the first row and first column, we're going to go to the first row and second column. Multiplying the first row and the second column, we're going to have 0 multiplied by 5 plus 1 multiplied by 7. Now, notice the position where we're going to put our answer should match the row and the column we're multiplying. For example, in the first position here, we multiplied the first row and the first column, so our answer was in the position, the first row, the first column. This answer that we've written in this position is because we multiplied the first row and the second column. So our answer is going to be in row 1, column 2. So the answer that is supposed to be here is supposed to be us multiplying the second row and the first column. We have a 2 multiplied by 1 plus 0 multiplied by 2, and then for our last element we're going to have 2 multiplied by 5 plus 0 multiplied by 7. This is going to be our kind of final answer, but we need to simplify it. 0, everywhere we have 0 multiplied by something give us a 0. So we have a 2 there, we have a 7, we have a 2, we have a 10. So the introduction of a 0 in the matrix made us a bit quicker. So this is how we perform matrix multiplication. The next time we do it, I'll be a bit quick. I've explained much of the information that you need to know. Here we have another question which is very much similar. We've been asked to find the transpose and express something we have here as a single matrix. Let's start with part A. We know what CT means. It's just the transpose. Whenever you see that T there, we rarely say CT, we just see the transpose of matrix C. Remember what we said is we need to find the first column and convert it to a row. This is what we should be expecting and thinking about in our head to get the correct answer. Usually for such questions, you just have to write the answer directly. 7, 1, 2, 6, 4, 5. But I've shown you the thinking process here so that you can just understand how it's being done. Next, what is a singular matrix? Or not a singular matrix, but a single matrix. A single matrix is just a term that's used to mean multiply the two matrices that have been given. As you can see, we have 1, 8, and 0, -1, 2, 5. These two matrices have been multiplied together. Now, you notice these two matrices are not the same like we had earlier. So, are we going to do the multiplication or just going to say we can't? Well, the first thing to do when you encounter such a problem and you're not sure is to perform a check that I'm going to show you. Remember, I told you knowing the order of the matrix is very important. This is where it comes very handy. The first matrix has an order of 1 by 2, whilst the second matrix has an order of 2 by 2. For us to be able to perform matrix multiplication for any two matrices, there's another condition that we need to observe. Apart from multiplying by each row by each column, we need to make sure that the number of columns in the first matrix is equal to the number of rows in the second matrix. Number of rows in the second matrix is supposed to be equal to the number of columns in the first matrix. Remembering that term or that sentence is kind of a bit difficult. However, you've seen how I've written this here. This is the order of the first matrix, this is the order of the second. If the numbers that are nearest to each other in the brackets here, if this number is the same as this number, then you can carry out matrix multiplication. And additionally, after you see that these two numbers here are the same, the solution of your matrix multiplication is going to be the numbers that are left. You can see we have 1 and 2. So 1 by 2 is the order of the matrix that is going to be the solution. We'll have 1 row and 2 columns. So let's begin. The solution is just going to be very easy. Remember, we've been given a hint. The solution is going to have 1 row and 2 columns. So when doing the multiplication, we'll just worry about 1 multiplied by 0 plus 8 multiplied by 2. And then we go to the next, which is 1 multiplied by -1 plus 8 multiplied by 5. That's the end. What remains is simplifying. We have a 0 there, so we just focus on the other number, which is 16. We have -1 plus 40. So that's just 40 minus 1, which is 39. So this is our solution. Let's look at another question here, which asks us to find the transpose of A and find PQ. In this scenario, it's easier for me to change each row into a column because there are just 2 rows whilst there are 3 columns. So in my mind, I'll quickly do that change, and the transpose of matrix A is going to be 1, -3, and 5, 2, 1, 0. You can see the first row has become the first column, the second row has become the second column. Next, we're going to perform some matrix multiplication. You might think this question is the same as the previous one, but it's a bit different. It's an extra question that shows you how to check if 2 matrices can be multiplied. So the first thing we'll do is check for whether we can do matrix multiplication. The first matrix has an order of 2 by 2, and the second one has an order of 2 by 1, 2 rows and 1 column. So because these numbers match, we are happy and can perform matrix multiplication. If they don't match, we can make a happy face. Next, we can also see that our solution is going to have an order of 2 by 1. This is due to the outer numbers, these outside numbers, the 2 and the 1. PQ is going to be 2, 3, -1, 4, multiplied by -2, 3. We will multiply the first row by the first column. So we'll have 2 multiplied by -2. And then we'll add -1 multiplied by 3. And then we'll go to the next row. Because this has 2 rows, remember the solution here, we have the order of the solution using the outer numbers. After we multiply the orders, we'll have 3 multiplied by -2 plus 4 multiplied by 3. Working this out, we have -4 plus -3, -6, and get rid of those brackets, plus 12. This is not difficult. We have -7 and 6. This is our final answer for matrix PQ. And now let's answer our final question, which is just going to consolidate the information we've learned in this video. Are we able to find transpose matrices? Are we able to understand what matrix multiplication means? Additionally, in this question, we are going to find the value of x. So let's begin with part A, which is something not difficult. The transpose of C. C is this matrix here. Our transpose is going to be 7, -1, 6, 0. By this time, I'm sure you're not getting confused how I did that. Next, let us find x for which AB is equal to C. Now, a key thing to notice here, all our matrices are 2 by 2 matrices, so we don't need to worry about checking because the order is the same. What is going to enable us to find the value of x is one property for matrices. If you have a matrix 1, 2, 3, 4, and another matrix 1, x, 2, 4. If these matrices are equal to each other, it means the value of the x is supposed to be 3. So 2 matrices can only be said to be equal to each other if every element of both matrices in the same position is the same. The element at row 1, column 1 is 1. The element at row 2, column 1 is 2 in both matrices. But I won't go into all those integrities. What you need to remember is the number here is supposed to be the number that's the same that is here. The number here is supposed to be the same number as that here. The number here is supposed to be the same as the number there. The number here is supposed to be the same as the number there. So let's do that and see how far we get. First of all, we need to find A multiplied by B. Matrix C is simple, it's all numbers, but matrix AB is something we need to find. You can also rearrange this as C is equal to AB so that it can be a bit easier for us to just keep the matrix C on our left. It doesn't matter which way you do it. As a matter of fact, we'll be first starting with finding AB. To find AB, we need to get matrix A. Remember, the order in which the letters have been given is the order in which you should arrange your matrices. Matrix B has -1, the variable x, 0, and a 2. What are we going to have after multiplying AB? Well, not something very difficult. We'll go step by step. 2 multiplied by -1 plus 3 multiplied by x. Then we go to this position here. We'll have 2 multiplied by 0 plus 3 multiplied by 2. Then 1 multiplied by -1 plus 0 multiplied by x. Wonderful, 0 is just going to give us something that we won't worry about. And the last is 0 multiplied by 2. We need to simplify. Just go step by step. -2 plus 3x. Here we have a 0, so we just worry about the 3 times 2, which is a 6. Here we also have a 0, so we just worry about 1 multiplied by -1, which is -1. And here we have a 0. It's interesting, we only have one equation, and that saves us from a lot of trouble. So at this stage, we can now use the relationship that we know. C is supposed to be equal to this matrix here. If you are very observant and you notice something, this matrix that we have is only different in this position. The 6, the 0, and the -1 have already matched with C. Let's answer the last part. So since we know this is supposed to be true, we can utilize the 7 and this first part here being equal, because for us to have that equation, like I explained, all elements should match in the same positions. So we have -2 plus 3x, which is supposed to be equal to 7. Simple equation that we can solve. 3x is going to be equal to 7 plus 2, which you can see is going to be an interesting answer. 7 plus 2 is 9. We divide by 3. X is just 3. Remember, whenever we solve the value of something, if we replace our answer, this 3 is replaced there. 9 minus 2 gives us 7. So we know we found the correct value of x. That's it for this question. You can see how we've utilized the various concepts of matrices to make sure we are able to multiply and find some simple twisted questions like this one that we've done at the end. Make sure you check the description for the solutions that are shared in a PDF. And if you have any questions about matrices, you can feel free to comment in the comment section. Most importantly, watch out for part 2, which will be helping you understand more about matrices.